Hello and welcome to this video where we'll go into missing data in Pandas. And this is quite interesting because when you're dealing with missing data, there's several strategies to deal with it. And it's not certain that one strategy is better than the other. And it usually is the answer for which strategy to pick is it depends. And you should also work closely with the domain expert unless you're not very familiar with the dataset yourself. So with this, I would like to go into Visual Studio Code. So in Visual Studio Code, let's create a file here called missingdata.ipnb. So we have a Jupyter Notebook file here, and I will call it missing data. Let's change the kernel so that we have our virtual environment here. So the virtual environment is just the UV that I've usually used, and then I've installed IPy kernel, Pandas, Matplotlib, and Seaborn basically. So if there's something more we need, we'll install it on the way. So let's change this to Python. I did it quickly by doing escape Y. So that is a hotkey for that. So let's doing some setup now. So when installing Pandas, you also get NumPy installed. So import NumPy as np, and import Pandas as pd. So let's do this np.random.seed42. So when we're doing this, we'll get repeatable results, right, from our random. So let's create a random matrix. And a matrix is basically just a table of numbers. So it's you can see it as it's a 2D array that we'll represent it with. So np.random.randint, so getting random integers. And this is values between 1 and 10, or actually 1 and 9. So it's 1 less, but that's fine for us. So random matrix, if I run this one, using Control Enter, you'll see the results here. It takes a little bit time first time. So you can see it's an array 0, 6. If I run it again, it's same. And I run it again. Oh, sorry. I run it again and it gives the same results. That's because random seed is 42. Okay, so let's continue now. So we can do put in a size, and the size should be n, n, where n equals to 8. Let's see, low, larger than equal to I. Oh, sorry, because I had another parenthesis here. Actually, this should not be a parenthesis because we have low and then we have high. So that is more correct. So now you will get the values between 0 and 9. That's why the first was a little bit strange before. We had 1, 10 in a tuple that we sent in. Okay, so now we have a matrix. It's represented as a 2D array. Okay, so now let's sabotage this matrix a little bit. I want to put in some nan values, and to do that, let's do like this. Random matrix.dice. What do we get? We get 64, right? So if you flatten this 2D array, you'll get a 1D array between 0 and 63. So we can use this to sabotage some values. So we can do like this. np.random.choice, and I will choose random matrix.size. So this will give me one value between 0 and 63. So if I continue, you can see I get a lot of different values, and then you can see that the random seed doesn't affect because the random seed just affects this cell up here. So we need to do random seed again. So I can do like this. I just want to show you that this gives different values, okay? However, if we do 10 here, then we get 10 values. So we get 10 indices. So if I run this again, we get 10 other indices. So let's do this. np.random.seed42, And then I get the same results each time, right? And using this, I would like to sabotage it a little bit. So let's do also like this. Replace equals false. And with replace equals false, it's a sampling without replacement. That means that whenever you pick out a number, you don't put that back and pick out the same number again. So there won't be a risk of picking out the same number. That is what replace false means. Now we have some indices. So we can call this index equals to this. And let's do like this. We can do random matrix dot revel. And you can see, oh, cool. Revel flattens the matrix. So we had the matrix as 2D arrays. Now we have flattened it. And by doing this, index, and we can see these are the values we get from the index, right? And it doesn't work because int argument must be a string, a byte-like object, or real number, not non-type. However, in order to make this work, we need to actually do like this. We need to type convert the ints to floats, because in floats, then we can represent none as np.nan. So by doing that, we do random matrix equals to random matrix times 1.0. If I do random matrix, you can see now it represents a floating number. We can uncomment and comment this one. Or actually, I want to show random matrix. And you can see what happens. Now we get a lot of nans. We have a lot of not a numbers here. That's cool. So now we have sabotaged this matrix. So if you don't understand all the things we did in NumPy here, no worries, because we won't work so much in NumPy. Instead, we have simulated some data, basically. The thing you need to understand is that we have simulated some data. We have simulated some not a numbers, so we have some missing values. That is the idea. So based on this one, let's go on to our data frame. I will call this scores equals pd.dataframe, random matrix, index equals to, I will have a list of f-string, player I, for I in range 1, n plus 1. So n plus 1, then we're up to 9. And if I run this one, you can see what scores looks like. Then we have here. That's basically what I did. So player 1 to player 8. Using this list that we get from a list comprehension as an index, right? Cool. So now we have index and we want to have columns as well. So columns equals to another list, f-string. I for I in range 1, n plus 1. I do Shift Alt F in order to auto format it. Okay, cool. Now we have player 1 to 8. We have round 1 to 8. So this is our data frame course. So let us work with missing data now. Missing data. And missing data, there are different types of missing data. There is none that we used before. So this is Pythonic missing data. It's a Python object. Operations done on Python level and not NumPy or Pandas. So this is a Python object that is none. And then we have nan. This is a floating point, not a number. It supports fast operations. However, all arithmetic operations with nan will result in a nan. So basically, this one is used by NumPy and in Pandas. And then we have NA or PD.NA. This is a missing indicator that can be used consistently across data types. So this is a Pandas version of not a number. However, in Pandas, they will treat nan and none almost interchangeably. So in Pandas, there are several methods that are used. So we have isNull. So this one will return true if value is null or none. So basically it's missing value. Null and none are used, or na are used interchangeably in Pandas. We have not null. This one will return true if value is not null. Then we have dropna. So this drops whole axis with nulls. We have na. It fills null values with certain value. Okay, so these are some basic methods in Pandas that can be used for working with nulls. So then we can start with this scores dot isNull. And you can see how it works. It goes into each element, and you can see true where there is null and false where there is not null. And then we can do similar here, scores not null. And you can see it's the opposite to this one. So they are complement to each other. We can do scores dot not. And you can see we get same results as not, because they're using it interchangeably. Then what happens if we do scores drop na? Scores.drop. So it removes everything. Why is that? Because if you look here, you can use not na, it's the same. So false means there's a null. False, false. So each of the rows had a null value in each of them. Axis equals to columns, or axis equals to 1. And then we can see that each column that had a null value will be dropped. So 4, 7, and 8, all are true. 7, true. 8 are true. 6, for example, had 2 false. Then we drop it. So if there's 1 or more, then we'll drop. We can do, for example, in case we know that, okay, so if there's a missing value, that means that the player didn't come to this round. And if that player didn't come, then that player will get 0 points. It's a walkover. So if we know this fact because of our domain expertise, we could do like this. Scores, for example, that is part of the rules of this game. If you don't come, you get 0 points. Then this is perfectly valid. So then we fill all the values with 0 that are nulls, right? Moving on, we'll come into missing data. Let's review what strategies we have. So I already know that there are different strategies, as I said before. So it depends on different types. For example, data set size. So if you have a small data set, then you might need to be more careful with data. For example, if the goal is to use it for machine learning or AI, then if you have a small data set, you need to be more careful with the data. If there's large data sets and few rows that are nulls, there's a higher chance you can remove those. So, however, there's also where is the nulls distributed? Are they, for example, are the nulls important in certain features? So that is quite hard to answer. So it's not always straightforward what to do. So there's different ways. You can also impute missing values. So nulls or missing values, you can impute them using, for example, the mean value or the median value or the most frequent value, for example, depending on your data and what is most suitable for that. You have to look at the percentage of missing values to know if you should remove them or not. In many cases, you need some domain knowledge on how to fill the data. For example, using domain knowledge or from the rules, for example, missing value becomes 0. Missing value in a column could be filled with mean or median. Missing values between 2 points, you can interpolate in between. There are several ways. You can use regression. It's a machine learning algorithm, regression, random forest regression, or similar regression in order to use all the other features, and using the missing value as the target, you can fill the missing value. Note, however, that missing data can negatively impact data visualization. It can impact arithmetic computations and summary statistics. It can affect machine learning algorithms negatively. So there's some kind of art in how to fill data. This is important to know. Important is that you discuss with the domain expert how and what type of strategies to use when you have a lot of missing data. Because data in reality is not so clean as in school usually. Okay? So let's continue here. So let's take an example. We take Seaborn, import Seaborn as SNS. Remember, this is the visualization library, so we can have sns.load dataset. I will show you actually from here. In the browser, we have Seaborn load dataset. And here in the documentation, you can see that Seaborn load datasets. You can choose, let's see, get dataset names, or actually not here. Here, I found it. So this is the GitHub link. So Seaborn data, they have a lot of different datasets which they have provided for you that you can use for visualization, test it out, and you can also use machine learning for it, but there's a lot of datasets here. So you just use the names here. For example, if you want ANSCOM, then you'd write in ANSCOM when you're doing the load dataset. But we want to have, let's see if we can find it, Titanic. We want to have this dataset, so titanic.csv. It looks like this. So if we just write Titanic in load dataset, then it will find this one for us. So here, going back to Visual Studio Code, we can type in Titanic here. And if I run this one, yeah, we get the Titanic data frame dataset as a data frame. So this is the CSV file which it has read in. So we can call it Titanic equals to this Titanic.head. Okay, and now let's continue. Now we do Titanic.info. And you can see that, oh, there's a lot of different data types. Interesting. And there's a non-null 891 here, and there's some that are null, right? And here we have a lot of nulls in deck. That was hard to find out for this data set. Cool. So let's count the number of nulls. We can count them using isNull, so Titanic.null. And then we get all these true or false, right, if they are null. And if we do sum, then all the false will evaluate to 0, and all the true will evaluate to 1. So if I do this, we can see each column, and because the sum will affect the axis column, So we see here each column has the number of nulls, right? So we see deck has a lot of nulls. Cool. So by doing this, we can continue to explore the dataset a little bit. So we can do sns.histplot, doing a histogram, data equals Titanic, x equals to age, for example, KDE. We can do it like this first, and we can see this is the distribution. We can do here x equals, or we can do KDE equals to true. And this is the estimated curve for this histogram. And you can see also we can divide it into different sexes. So hue equals to 6. Then we have female and we have male. So this is quite cool that we can do that. And how can we do that? Because if we do, for example, Titanic.value counts, Titanic, we can do, for example, here, sex.value counts, and you can see there's male and there's female. So there's these types. So if you take in this parameter into the hue, and it will divide it into the different categories that exist there. Cool. So moving on. Imagine now that you're a historian, and this person advises us to use the median age of the corresponding gender to fill in the missing age. Like this. So imagine that we have talked to a historian, and this person advises us to use median age of the corresponding gender to fill in the missing ages. Because we remember that we had a lot of nulls in the age, right? We have 177 here. So what to do here? Okay, so this is our goal then. We need to find out the median age. So let's do that. So Titanic of sex equals to male. And here we have all the true false, right? Titanic of this one. So Boolean mask. Now we get all the corresponding rows, right, to the males. 577 that we knew before. So we can take out the age column. And we can see here, there's a lot of values, but there's nans as well. So if we take median of this one, then we'll get 29. Okay, cool. So we get 29. So then we can save this one. So median male age equals 29. Median male age, right? So this is just the representation of it. So let's continue with the female one, and now we'll use the query syntax. So Titanic.query sex equals to female. And let's see, we need to have a quote there. And with this, I would pick out that median. Like this. So median female age, 27, right? Let's see now. Let's do like this. In order for us to fill it, we need to do like this. Titanic.loc. We find out Titanic of sex equals to male. And we find out the age column. And by doing this, you can put in this condition here. And you can take out the column that you want. By doing this, we can change just this column with the new column that we get. So to put in the new column, we can copy this one here to age. So equals to this one. So Titanic, we find all the male, their ages. And, or actually we can do like this. We copy this one again. So this will get exactly same values, right? But we do dot fill now. And what do we fill? We fill with the median male age. So if I do Titanic now of age, then you can see that number 5 here, the index 5 will be changed to 29. Actually, we didn't get that. We can do dot head here. And you can see dot head 6, and you can see 5 become 29, right? So continuing with this, we'll do same as we copied this one, and we'll do for the female as well. So female, and we change it with the female age. So then we can do Titanic age. Let's see. Yeah, exactly. Then we shouldn't get any nulls. For example, we do like this, Titanic.isNull. IsNull of isNull.sum. Then we can see that age don't have any nulls, right? So now if we do a SNS.histplot as before, and we should expect that for the males and females, we should have a lot of values around 30, right? Around 25 to 30. So let's do that. Data equals to Titanic, X equals to age, KDE equals to true, and hue equals to 6. So if I run this one, we see a huge values here between, this is around 27, 29, 30. And that is what we expected because we filled it, right? So that was quite cool. So let's move on with some more things that we can do with this data set. We can come into something called aggregations and group by. We have different types of aggregations. We have sum, we have median, min, max, we have count, right? And so let's do like that. We want to find the survivors. So Titanic dot parenthesis group by sex. What will happen? We get a group by object, right? And with this group by object, let's find out different things. We want to find survived. We want to find age. And we want to find dot mean. So here we get ages 27 and 30, right? And we get the survived. So these are, you can see it's 27 and 30, and that's because we have put in a lot of 27 and 30, right? So they don't have so many missing values anymore. So this is not really accurate, or it's accurate if we based on what our historian said. Okay, but the survived is quite interesting. So you can see that, okay, most of the survivors were female, and that if you have seen the movie, that makes sense. So let's continue now. For I in survivors, we can call this survivors dot index we can find out survive percentage. Survived percentage equals to survivors. It's actually quite a hard word to spell. Log I, comma, survive. So I pick out each of the values here, and I will do times 100. Like this, survive percentage, and I will print it. F string, percentage survive. like this, colon, colon, survive percentage. And you can see here how many it was, and we can change it to colon 0.1f, so we can format it a little bit nicer with f-string, and we can continue with some more aggregations. For example, we can do Titanic.group by, we can group by the class. Okay, and now we need to do age, comma, pair. I need one more parenthesis like this, one more bracket to get both of them. And I need to put in an aggregation. I can put in max. So here we get age and we get pair. Let's see, there's a future warning. The default of observed equals false is deprecated and will be changed to true in a future version of Pandas. Pass observed equals false to retain current behavior, or observed equals true to adopt the future default and silence this warning. Okay, so let's continue. Let's do that. Observed equals true. So this one disappears, the warning. So it means that categorical values, only the observed values will be shown of the categorical values. So those that are not observed won't be shown of the categorical, but that doesn't affect here since these are continuous values. So let's continue now. So now we have done using the max, right? We could continue here with Titanic.group by. We can group by survived, and we can take out the sex, and we can do value counts. Right? And here we see that for survived 0 or 1, we do the counts, we do the value counts for each of them. So how many of the males have died, how many of the females have died, how many of the females have survived and males have died here. Cool. There's another method that is quite interesting. It's called ag. So let's do that. Titanic.group by survive .ag. We put in a dict of age equals to mean, comma, pair equals to median, for example. So what this does is that we take the median of fair and we take the mean of age. So with the ag, you can put in different type of aggregations. So you don't need to use the same aggregation for each column, right? So that is quite interesting. Okay, so yes, we can do also. I'll leave the rest for you to look into the lecture notes. So with this, I would like to thank you for watching this video on missing data. We've learned different types of strategies. We've learned how to fill data. We have simulated our own data. We have worked a little bit with aggregations and group by. So thank you for watching this video and see you in the next one. Bye.